Okay, welcome everybody to my session about Elasticsearch Search API. So Elasticsearch Search API is a module we recently contributed to Drupal.org. It's currently still in a dev stage, but today I want to introduce you to it and talk about its features and how it can help you in building your own custom Elasticsearch implementations in Drupal. So the module is developed by our teams at Cegeka and VDAB. It's currently in a dev stage, contributed to Drupal.org, and it's a module it's a framework to help you build your own custom Elasticsearch implementations. So first, little introduction about me. My name is JOpdebeeck. I am a Drupal developer working at Cegeka. I've been working now for about 6.5 years. Oh. See how I can do that. Oh. Is this better? Yeah. Okay, so I'm currently working about 6.5 years at Cegeka. Started in Drupal 7, and currently I'm working on projects for the VDAB, which is the Flemish organization that helps people with their careers and helps people to find a job. Currently we are working on the public website, the VDAB.be. We also have the intranet, which is an internal site for people who are employed at VDAB, the extranet for external partners, and the werkgevers, which is Dutch for employers, a subsection of the public website for employers that employ people. Currently, most sites are upgraded to Drupal 9. And the latest site is werkgevers.vdb.be. We're in the process of upgrading to Drupal 9 as well. So what I'm going to talk about today, first a little bit about the origin of the module, how the module came to be, the Elasticsearch Search API module, what its purpose is. Then we're going to go over some of the key features that the module provides. And then we're going to see how you could set up your own search pages using the module as a framework, and we'll see that also with a live demo. So first, the origin. So at VDAB in the past, when it was still running on Drupal 7, our search was powered by a Google Search appliance. When we were going to do our upgrade from Drupal 7 to Drupal 8, at the same time, around the same time, also our Google Search appliance licensing. It was our Google Search appliance machines were going to be end of life, and we needed to have a new search solution. And at VDB, they landed on Elasticsearch to implement their searches. And we opted to completely build the integration with Elasticsearch and Drupal fully custom, to have a full control of the different search strategies that would be used, the boosting of certain search results, the theming, custom functionality. So we opted to build the integration fully custom. And luckily for us at Cegeka, we already had a custom Elasticsearch implementation for a project for FedNot, which is a website for notaries, and we already had made there a custom Elasticsearch implementation. And what we did was we took that custom implementation and stripped out everything that was really specific to that project to create a sort of base framework starter kit from where we could then build our custom Elasticsearch pages at VDAB, to have a base module to help us reduce the development time that we would need for the VDAB search pages. Initially, this starter module was hosted internally at a Git repository at Cegeka, but then now recently we contributed to Drupal.org, and also all our search pages at VDAB are using now the Drupal.org version of the module through Composer we pull that in. So a very important thing about the what we needed for our search pages at VDAB was the ability to work with facets, and that was also custom implemented in the FetNode project. So we could start with a really nice starter kit to start building our search pages. So the purpose of the module, the target audience of the module are developers, because it needs to be used as a framework. It provides a lot of out-of-the-box Elasticsearch functionality that you can use when implementing your own custom search implementations. So you would typically use or extend upon the existing services that the module provides. It has a lot of out-of-the-box searching strategies that can be used. Some of these searching strategies need to have certain index settings or field mappings applied to the index, and our module provides services that apply these indexes and mappings automatically, or you can then build your own search strategies by extending our services, and the communication between Drupal and Elasticsearch is handled by our module, and you can focus on just implementing which kind of field mappings or settings you would like to add, and add that to your own custom implementation. It also, a big part of the module also the usage of faceted search. Our module has a framework in place to easily help you add faceted search to your search pages. The main goal is, of course, to reduce your development time when building custom Elasticsearch based modules or implementations. In order to do this, our module depends, of course, on other contributed modules. One of them is Elasticsearch Connector, and another one is Search API. Elasticsearch Connector is used to set up the connection to the Elasticsearch database. Our module also uses some events and some functions that Elasticsearch Connector module provides. And then to create your indexes and to select your fields and data source that you would like to index, we use, of course, Search API module. It's a very Search API is a must-have module when you are doing custom search development, because it's very very handy to, for example, create your own search processors that allow you to add custom fields to your index and do custom search functionality based on those fields. A good example of that at VDAB, for example, is we had to one of the business requirements that they had was that they wanted their search pages that were deep inside a menu. So you have the general menu and search pages that are lower in the menu. They wanted to have them also lower ranked on their search pages. So the depth of a menu is not something that you can default add with Search API to your index. So what we did was add a custom Search API processor for this, called it menu depth field. Here's a snippet of code from that custom processor. And what this does is it's going to, when indexing our nodes, it's going for each node to also look up the depth that the node has in the main menu and add that to that field. So the depth of every node is going to be indexed, and then later when we actually do our search query to Elastic, we can add, for example, a decay function score that's actually going to reduce the scoring of your documents based on how deep they are inside the menu. So the deeper the pages that are deep inside the menu are going to be more and more decayed from score, and that way we could make sure that the pages that are shown up at the top would be pages that are very high in the high in the menu, and pages that are deeper in the down the menu tree would be pushed down to the bottom. So that's an example of how you could use custom search API processors. Elasticsearch connector is of course needed to make your connection with the database. This is an example of the Elasticsearch connector backend here, where we made a connection to our Elasticsearch server. And here you have a screenshot of the Search API backend. This is a screenshot from a test environment from the intranet at VDAB. So you can see we have quite some indexes now at VDAB. And also each one of these indexes has their own search page, and all these search pages are built upon the our Elasticsearch Search API framework. Inside this index then with Search API you can define which fields you would like to index. These are like the standard Drupal fields that can be added then, depending on which content type or which data source you are indexing. You can select the types, you can select the boosting. The boosting, I will go into detail further how we use that field later. But yeah, this is to have a general idea how Search API, the backend of Search API looks. So now I'm going to go over some key features of the module. So searching and rendering, how do we handle that? We have a service that builds the search query that we send to Elasticsearch, and we decided to use Elasticsearch multi-match query. This works very well in combination with Search API, because Search API is going to allow you to create index each field of your entity individually, and with a multi-match query it allows us to do multi-field queries. So to match a certain keyword to any of the fields that are indexed. Multi-match queries have different types that you can select for the query. Our module default uses the most fields types. You can, of course, if you create your own custom Elasticsearch implementation using our module, you can always extend or override the Elasticsearch query builder and select another type. I'll go over some other types there are, for example, best fields or cross field. What most field type does is it's going to match your term with any field of your index and then combine the score of each different field. Other Elasticsearch types that you, multi-match query types that you can use are best field, which is where you only use the score of the fields that is matched best. There's also there's a cross fields type where Elasticsearch is going to handle all your fields as though it was one, all your fields with the same analyzer as though it was one big field, and then it's going to base its scoring on that. We landed on the most field type because we did some testing with it, and that yielded the best results, and was most easy for us to tailor our search to tailor the scoring of our search was most easy with the most field type multi-match query. When then querying Elasticsearch, we of course get the results back, and in this result there is an ID key. These are the IDs of your indexed entities, and when the results are returned, we're going to use those IDs to load up the entities in the Drupal backend, and then we can render them in a view mode. By default, we use the search index view mode of your entities, but of course, again, you could change this view mode if you override in the controller the render functions. If you override them in your own custom implementation, you could opt for another view mode, but by default it's going to use the search index view mode. The entities are then rendered in this view mode and sent to the template. Our module provides some templates out of the box, and then it will be, your results will be rendered on your pages in that specific view mode. Here's an example of an Elasticsearch multi-match query. This is an example of the demo that I will give later. So this is actually an Elasticsearch query that how it is built by our module. You can see here it's a multi-match query. We have certain fields that are being queried. For this, it's a basic page content type, and it has a body field. PageType name is the name of the taxonomy term that is linked with that entity. And then we have the title, and you can see here it's a most fields type query. Elasticsearch then returns a result. In this case, it's only what we searched here for you see in our query we search for quick, and we have one document match here, quick brown fox. It's the name, the title of this node, and here you can see the ID key. So it's entity node 1, and that's what we then use to in the backend when the results come in. We use that ID key to load the node and render it in the search index view mode and display it in the results. As you noticed maybe on our query, after each field you can see there is a number there. This is the boosting that we also use, and that comes that is used in our module. With multi-match queries, what it allows us to do is do a per field boosting of the score of each field. It is applied on when querying Elastic, so no re-index is needed to change your boosting. The boosting is applied when querying Elasticsearch, and this works also very nicely with Search API, because as you saw on the Search API screen, we could select the boosting for each field, and that we are using the values of those fields to actually add boosting for each field to our multi-match query. And that way we can easily make some certain fields more powerful when searching, so increase the scoring of certain fields, and that depends on how your search is, how you would like your search to be built up, which fields that are most important on your index. For example, at VDAB, the node titles are boosted very highly. And another thing that you can do, for example, to easily change the scoring of your entities is, for example, you could add a taxonomy term with certain keywords to your nodes. You index that taxonomy term, and you give it a very high boosting. And when people search for certain keywords and you want them to land on certain nodes in the result page, you could then add those keywords to your taxonomy field, and that way you can play with the boosting of your return documents. Here's an example of again of the Search API backend. So you can see here you have the body field. We can alter the boosting through Search API backend, and then that's going to be added. That number is going to be used in our multi-match query. In this example, to boost the body field, it's set on 5. Title is set on 13. So that way you can play with the boostings of your field. Another thing that you can see here in the fields is that each full text field has an Ngram field as well. So that's another feature in our module. Our module adds an Ngram tokenizer. And what are Ngrams? So basically, Ngrams, an Ngram is going to break. An Ngram analyzer is going to break down your words into smaller words of a specified length. So this is very useful, definitely when querying large languages, to actually have, if you do a search term, to still have results on partial matches of a word. So our module adds an Ngram tokenizer to the Elasticsearch index, and it also adds that analyzer to each text field that is indexed on your Elasticsearch. By default, it's going to create Ngrams of length 3, so it's going to take your value of your text field, and it's going to split it up into Ngram lengths of 3 characters. But these lengths can also be changed if you do your own custom Elasticsearch implementation based on our module. You can change these lengths through service parameters. At VDAB, for example, we use Ngrams of length 6, because Ngrams of length 3 gave a little bit too much results, and yeah, the business decided that they wanted to have matches to split up words into 6 characters each. So this is an example from the Elasticsearch documentation how an Ngram analyzer looks like. This also our module actually does this in the backend. It puts the analyzer to the index. Here you can see it's an analyzer with min-max grams of length 3. This is parameterized in our module, so you can, when you add an Ngram analyzer, you can change that. And this is an example of how it looks when an analyzer is run on a piece of text. Here we have the sentence two quick foxes, and you can see that the result of running the analyzer is that it's going to split up this text into strings of length 3, and then this field is then queryable, and that way you can have matches on parts of a word instead of having to always search for the full word and then only have a match then. This is an example of Ngram in action on one of the search pages at VDAB. You can see here we are searching for Delaar, D-E-L-A-A-R, and we're getting matches on the middelaars because the middelaar is 12 letters, so it's matching on our Ngrams are length 6, so it matches on part of the word here, and you still get search results because we got a match with our Ngram field. Another feature that our module provides out of the box is Autosuggestion. So what our module does, it adds a completion suggestion to the title entity, to the entity title field. And what this allows you to do is that you get search as you type functionality. So when you are typing in the search box, you get search suggestions based on found titles in your search form. How this works is that there's an autocomplete endpoint that our module provides when searching in your search form, and request is sent to Elasticsearch to return suggestions, and these are then shown in the autocompletion of your form. So how this works is that our module adds a search suggest field to Elasticsearch. It adds that field to the field mapping, and this is a completion type field that Elasticsearch offers, and all our values of the title field are then copied over to this search suggest field, and it's that search suggest that is getting queried in the backend and returns search suggestions. By default, our module provides a suggestion for the title field because that's a system field in Drupal. Of course, if you have other fields in your own custom implementation and you would like to add suggestions to that, you can implement our suggestion interface and build then a suggestion for your own field. And for example, maybe instead of getting autocompletion on the title field, you could maybe do it on a keyword field or another field that you have indexed. This is an example on VDAB, where you can see here we are searching for werkzoekende and in our search box, and we get some autocompletions returned from Elasticsearch, some suggestions of titles of nodes. This is the snippet from our index mapping. So this is the search suggest field. It's a completion type field. And you can see here also on the title field, we have a copy to entry. So it's going to copy the values of the title to this search suggest field. And it's this search suggest field that gets queried by Elasticsearch. So this is an example of also in Kibana. So what our module generates. So this is also from the demo. So here you can see we are doing a search suggest query to the search suggest field on QUI. So we're starting to type. It sends a search suggest query to Elasticsearch, and we can see we had Elasticsearch returns a match here, and in the return suggestions we get that same quick brown fox title document, and then this suggestion then gets added to the autocompletion of our search form, and then we can autocomplete our search term to the node title. Another feature that our module provides is a did you mean search strategy. So this is done by adding a title suggestion service to the search page, and this will add a phrase suggestion to your search query. So when querying your Elasticsearch, we also do a query to Elasticsearch to ask for suggestions on the search term. By default, this search suggestion is also only on the title field, but again, other fields can be added if you do your own custom implementation. And if this suggestion, it needs a special mapping up front to work. Our module also provides that through a strategy service, so it imports the needed index settings and mappings to your Elasticsearch. During querying, then we query Elasticsearch, and if we get any suggestions returned by Elasticsearch, we render them in a sort of did you mean block. So here we misspelled the words werkzoekende, and we get back a suggestion of a search term, and that's rendered on the search page. And then another big part of our module is, of course, the generation of facets and faceted search. So facets are useful when you are searching in big amounts of data to filter down and narrow down on a specific portion of your search results. So they are typically filters, and then you can filter if you do a certain search term, you get back your results, and then you can filter down using facets on a certain to only get certain types of search results back. Typically, usage of this in Drupal is if you is on your content is by the usage of taxonomy terms. For example, if you have different page types and you have different terms, you could create a facet for that to filter down on to only get pages back of a certain taxonomy type. But another example is content types. So if you have an index that indexes different kinds of content types, you could build a facet so you can narrow down on only nodes of a certain content type. Or Boolean fields, for example, on the internet at VDAB, we have pages that are archived and not archived, and we also build a facet for that to only so you can filter down on pages that are archived or to only return pages that are not archived. Our module supports the building of facets for flat and hierarchical facets. So if your taxonomy term is hierarchical and has multiple levels, our module also supports to build a facet for that. And the setup of a facet is quite easy. It requires that we have a lot of base interfaces and classes to help you get started on building a facet. For example, if you want to build a facet for a taxonomy that you added to your index, you could extend the term facet base class. That would be a service then that you add to your module in a certain format. Here you can see the format is an Elasticsearch search API dot facet control dot myFacet, and myFacet would then typically be the system name of your taxonomy. And then in your controller function of your search page, which extends the base search controller of the base module, so Elasticsearch Search API, you would then override the get facets function and add your created facet to the array that function returns, and then you would have added a facet to your search page. So here an example of VDAB of our facets on the intranet. You can see here a small portion of our facets. We have here the content types, the different taxonomy terms, kind of pages, which is a different taxonomy, and then also a multi-hierarchical taxonomy, themas. So you can see this is a taxonomy that has multiple levels, and our module also can build up the facet even though it's hierarchical. So when building your own search implementation using our module, what would you need? You, of course, set up your connection to your Elasticsearch server through the Elasticsearch connector. You would then create your indexes and add your fields through Search API. In order to apply the required index settings and field mappings to make the strategies work, you would run the Elasticsearch Search API cron job. This job will then place the field mappings and index settings, for example, your Ngram analyzer or your SearchSuggest field if you're using those features on your custom implementation. And you could then start building your own custom search module using Elasticsearch Search API as a framework. Typically, you would start with defining your search routes. We have a routing.yaml.example file in the module. You would then add an endpoint for your search page, an endpoint for the filter. This is an endpoint that's being used by our module to send the queries to Elasticsearch and update the search results. You also have the option, I forgot to mention, when searching, to let your results be updated through Ajax or manually by refreshing. So refreshing the page when you're doing a search request. When you're using facets, it's best to use the Ajax functionality because that's a little bit more user-friendly when you're filtering down on your facets, that it gets updated through Ajax. And then you would, on your search endpoint, you would then hang your own search controller that extends the Elasticsearch Search API search controller, and then add a search form by extending the search form that is provided by our module. And from there on out, you can add, extend, or modify services and features that are provided by our module, and start developing your own custom Elasticsearch implementation. Our module also has an example submodule inside to assist you in starting your own Elasticsearch implementations. It is a little example module that can be used to look at references, how you could get started when you start building your first Elasticsearch module using our Elasticsearch Search API as a framework. So I'll do a live example of using our module. So what I have here is we have set up through Docker, we have set up Elasticsearch Drupal website. We have enabled the Elasticsearch connector module, Search API module, and we also, of course, our Elasticsearch Search API base module. We have enabled that. We have a connection to our Elasticsearch server. As you can see here, we have set up, so Elasticsearch is also running in our Docker container. We have an active connection, and then through Search API, we have created one index. In this index, we are indexing basic page. So we are indexing content of the type basic page, and in our fields, we indexed some fields. So we're indexing the body, the page type, the title. Page type is a taxonomy that we added, where we will build a facet for, and then we have a little bit of content. I had prepared more content, but unfortunately, I had to remake my Docker container, so I lost some of the preparation that I did for the demo. But I'll still try to show you something. Here in Kibana, we have our Elasticsearch running. So what we also did was run the cron job of our Elasticsearch Search API to apply the index settings and the mappings. In our index management of Elasticsearch, we can verify that these settings are indeed imported. In our mappings, for example, we can see we have our Ngram analyzer running on our text field. We have our SearchSuggest field running, so everything is set up, and we can start to build our custom module. I'm just going to. I've prepared the demo beforehand, so I'm going to copy paste over some pieces of code. First, I'm going to enable the module. So at this moment, we only have a demo module, and it only has an info file. First thing we're going to do is create the routings where we want our search page to be. So what we needed was, of course, an endpoint for the search page, an endpoint for the filter that will be used to query the Elasticsearch, and then an endpoint for the autocompletion on our search form. So I'll add that. We also need, of course, a controller. So here you can see this is the controller we will use for our custom Elasticsearch module. It extends the base search controller of Elasticsearch Search API. Here we defined our own search routes, so we overrode those functions and added our search route to it, the search and the filter. So I'm going to add this. We have our search form that extends the base search form of our base module. Currently, we only say because we extended the autocomplete route, we only use that, and we don't do any other changes to the base search form. So I'll add that to the module. And then for the facets, in our services, we have one facet, PageType, as you can see on our site. In the Search API fields, we had the field PageType field. So we want to make a facet for that because it's a taxonomy. So we add that as a service. to our module, call it PageType. And what we needed to do was then create a PageType facet control that extends the term facet base. And here we need to add this as well. I'm going to add that. And what this does is, the term facet base handles the generation of the facet and also how the filtering down of the facet. The only thing we have to define when we extend it is, of course, our vocabulary name that we're using, which is in this case PageType. So I'm just going to verify if that's indeed the name of our taxonomy type. So we have the PageType taxonomy, and it's indeed PageType, so that's good. So we can say that we want to select multiple facets. It's not a hierarchical taxonomy, so we set that boolean to false. And we also want to include facets that are empty. So when we generate the facet, if there are any facets that are still empty, it's still going to render that. And then for our field name that we have indexed on our index, it's field PageType. And that's indeed, if we look at our search API, indexed fields, field PageType is indeed the name of our index taxonomy. So we have that. In our controller, we of course need to say which facets we want to use. This is the PageType facet that we want to use because that is the name of our service here that we added for that facet. And then we are ready to set. I'm just going to quickly clear the cache. So here I'm just going to go to my Docker container and clear the cache. And let's see if we get a search page back. So our endpoint was on demo/search. Oh, we have an error. Just quickly check. I'm currently getting weirdly an error that he's complaining about the search form. Just maybe clear cache through here. I'm not sure why, but it's not finding my classes, even though maybe something went wrong when copying it over. So yeah, the demo failed, I guess. It's very unfortunate because I made it up yesterday, and I wanted to save time. I saved it in a finished state, and now by copying over, but unfortunately it's not finding not even my classes. It's giving me errors that he cannot find the controller class and etc. So maybe something. So unfortunately, I can't show the finished demo, but yeah, I hope you still had an idea how you could what you needed to set up a search page. From this point out, if you have this, the result would have been a search page that has the results, and then your facets that you created, which would be very basic. But this is what you would need to do to set up a very basic search page with a couple of facets, and then from there on out you can add extra functionality on top of your class, on top of your module, depending on what you would need in your search implementation. Yes. Yeah. Yeah. I will go to VDAB, test environment. So here is the search on VDAB, for example. I'll just search something. So these are the facets that I showed earlier. So these are hierarchical facets, and we also have normal facets. When we filter down on them, they get, you see the search results are being filtered. We have a suggestion here. So if we start typing, we get our search suggestions back on the node titles. Let's say we would mistype a word, like we wanted to spell Brussels and we mistyped it. We would get a "did you mean" example. So we can then change that and then have another search entry. These are the facets. Yeah, you can see the Ajax working here. Maybe an important note also, I've mentioned when we are rendering the search results, we render them in a search index view mode. Now, by default, it is not included in a module that you can. What you can see here is that we get the highlighting back from Elasticsearch. So here, for example, we're searching for Brussels. We get highlights back in the search results. So what we did at VDAB was we created a pseudo field on the search index view mode. I can quickly show that. So we have in our content types, let's say we go to a basic page view mode. Oh. So here we have the search index view mode, and here we have an Elasticsearch snippet field that we added. And in our own custom Elasticsearch implementation, what we do is when we render this view mode, Elasticsearch returns highlights, and we place them inside this field when rendering. Now, we cannot really implement that by default in the base module because it depends a bit on which fields that you indexed and what are the names of the fields that you indexed. So not every field is suitable to generate a snippet from. For example, if it's a very short field, you don't want to include that in your snippet because it's going to be a very short field. Typically, you would more use a body field, for example, to extract your highlights. But because of the naming, how you name your fields in your index, it's hard to add that by default in the base module because you need to say which fields you want to use to generate your highlights, and those names can be different from project to project. By implementing custom search pages, you can add the function. So our module has a lot of functionality out of the box, and the rest is what you add to your own search implementation, of course. Another example is on the main website, on our search here. This search does not have facets. This is also built using our base module. You can see there are no facets here. That's not needed on the public website because it's very straightforward. It has a lot of basic web pages. But what we do have, for example, here is a key match block, for example. Now, this is also not included in the base module. This is built upon our own custom Elasticsearch implementation that uses the base module, but we extended it. And for example, in the search results here, we added these key match blocks. And basically what they do is, this is a content type, key match content type. And when certain exact specific search terms are matched, for example, if you search exactly for VDAB, we will see it in the backend and we will load up a key match content. We will load up a key match that matches that term and then add it on the top of your search results. So these are examples you can customly do with our module. Or here this block here, this is a call to an external service. That this block is then also added to our search result page. This is also customly built at VDAB on top of our module, on top of the base module. So quickly, for the future of our module, so it's actively used at VDAB, but on Drupal.org it's still in a dev stage. We are aiming to create a first beta release of it. What still needs to be done is very important to improve the documentation, because it's going to be a module that will be mainly used by developers. It needs to have good documentation to see how every part of the module works and how you can implement it or extend it. We would also like to add more parameterized features, like you saw with the facets. We could, through booleans in the constructor, say we want a hierarchical facet, we want to be able to select multiple terms, or we want to be able to show empty facets. These are easily included with booleans. We could reduce the need of extending or overriding certain functionality if we added more of those parameterized features on your search. So you can easily, for example, extend the controller and just place some booleans values to have different kind of search functionality, instead of having to extend the query builder, for example, and add functionality yourself. And add maybe more base functionality, like I said, with the pseudo field for creating search highlights, as you saw at VDAB, on the VDAB searches. We could also try to implement that in the base module, or maybe like the setup of it, and then you could add your own field names. You could say which field names you would like to use to generate the snippets, but that's not currently included in the module. And then another thing, currently it's supported by Elasticsearch 7, so our module supports Elasticsearch 7. When our module was still on our internal GitHub at Cegeka, we supported Elasticsearch 6 and 7. Now at VDAB we upgraded to 7. And we also decided to only contribute the Elasticsearch 7 compatible branch to Drupal.org. Elasticsearch 8 is out now, and we will also, of course, update our module, and it's probably going to be a different release than that is Elasticsearch 8 compatible. So you can then choose, depending on which Elasticsearch server version you're running, which branch of the module you would need. Some closing remarks. Our module should be seen as a framework, a toolbox, or a starter kit for your own custom Elasticsearch implementations. Our goal with it is to assist you in building your custom pages and to easily add your own functionality and make it so you have a nice, quick startup when developing your own search pages, that you don't have to do a lot of work beforehand to set up your connections or import your mappings or do basic searching. So you can immediately start building your own custom functionality and have a working, out of the box, a working search page. That was it. If there are any questions, please feel free to ask. And then thank you. It's my first time speaking at a convention. I would like to thank the organizers to give me the opportunity to present you with this module. Unfortunately, the demo failed, but yeah, that's unfortunate. If there are any questions, yeah, feel free to ask. Yes.
What was the question?
And why don't you use the facet API to build your facets?
We had, I have no experience with the facet API, but with the facets, yeah, we already had built that on the FetNode project. We had a custom facet implementation that we made, and we used that to in our own module to create the facets. So it was already the facet part of the of our module was made at the FetNode project, and I'm not sure why back in the day they didn't use facet API. I'm not familiar with it, but yeah, we had a custom implementation on that, and so we continued using our custom way of building facets.
I love this one. Anyway, very nice presentation. Thank you for doing that for us. You said that you had to change from one search, from one indexing engine to another. What made you go with Elasticsearch and not grandfather Solar or something else that is that was well implemented?
Yeah, it was not my choice to use Elasticsearch, but yeah, at VDAB the higher up they decided that they were going to use Elasticsearch, and VDAB already had Elasticsearch servers built up for other teams, and they decided that it's for all of VDAB that Elasticsearch needed to be used, and that's what they were going to support. So we also had to build our search pages on Elasticsearch. So I personally don't have any experience with Solar. I only have experience with search with Elasticsearch, but yeah, that was not a decision that we could like push ourselves.
I also noticed that other companies, Flemish Broadcasting, the VRT, and also FedNot, for example, that they take this decision architecturally that we're going to index on Elasticsearch, and it was very similar. You didn't have to choose, and with Search API you can then connect to it. I see another question, Jeroen. Is that okay?
Yeah.
So first of all, thank you for being a first-time speaker.
Thank you.
And don't worry, everyone that has been a speaker here has tried to do a live demo, and it always fails.
Yeah,
so welcome to the club.
It's really weird because yesterday at my home I made sure everything worked, made sure everything was set up, and I then copied all files to an example folder. And yeah,
it's why it's called Murphy's Law.
Yeah,
okay.
It seems.
The one question I wanted to ask was, so do you know about the Elasticsearch helper module? And one thing that, because I use that module, one thing that I like about it, and it's a bit also one of the advantages of Elasticsearch, is that you can get from Elastic all the search results as REST objects. And then use kind of some headless Drupal to directly display from Elastic to the client the search results without having to process them through Drupal, which I'm pretty sure if you use Search API you have to do.
Yep. Indeed.
Okay. On one end, you also lose the ability of stuff like views integration and stuff that you can have from using Search API. Do you know the Elasticsearch?
No, I don't. I've not Elasticsearch helper, or how is it called? Yeah. No, I've not used that one.
Okay. Good.
I'll look into it. But yeah, indeed, we have to. That's why I said like with Search API, the Elasticsearch returns the query, and we really process that the results. So we process the results that are returned by Elastic, and then we decided, to use view mode. Search index is the default view mode, and render our nodes. But I'll look into that module. See, I've not used it.
It's also a user choice to have some fields showing, and I think that's also why at the beginning it was chosen to add Drupal content in the search results.
Any other questions? No. Okay. Thank you all for coming. Thank you.